Hey there, welcome to Learning Labs. Today we're in meteorology. We're talking chapter 2, which is all about weather. And specifically today we're on 2.6, which is all about air pressure and wind. Okay, here's some terms that we're going to talk about, as well as the main idea of this chapter, which is all about differences in air pressure on Earth. Earth's face causes winds. So one day you might be asking your parents, where does wind come from? Well, I'm about to break it down and show you, okay? Your parents probably lied to you. Anyways, check it out. So how can air pressure change? What do you mean change? Let's take a look. Air pressure depends on the height above Earth's surface. So if you remember way back, we talked about how you closer to the ground you are, the more air molecules are on top of you, therefore more air pressure pushing down on you. Yeah? So if you're really high up, less air pressure. The denser air weighs more than equal volume of less dense air and pushes down harder. So if you have hot air, for example, hot air is the molecules are moving around really fast. Okay, they might take up the same amount of space as cold air. Cold air is, they're all cold, they're huddling up together, they're all really close. Okay, they might take up the same volume, but they can squeeze in more molecules together closer because they're cold and shivering and they're not taking up a lot of space. So there's more of them. Versus hot air is beaming around. The molecules are taking up a lot of space. They keep knocking everybody out of their space. So there's less molecules actually in that space. And what do we talk about molecules, right? If there's more of them in the cold air, then they're denser and they weigh more. So hot air has more guys running around, same amount of volume, less dense. The amount of water vapor, so nitrogen, oxygen, and other gases are in there. The water vapor molecules weigh less than oxygen and nitrogen molecules. So moist air exerts less pressure than dry air. Really cool. I actually didn't know about that until I started learning about this stuff. That water vapor molecules weigh less. You'd think that the water would make it heavier, but actually it's the opposite. So looking at this diagram here, but if you have a container and it has water in it and it has air in it, and you heat up that water, okay? So the water is being heated up and the air on top of it is also getting heated up. Then you close that container with the hot air and the hot water and you pour really cold, ice cold water on top of that container. That container will be crushed inwards because the cold water on top and the cold air on top is more dense, has more pressure and pushes in to the less pressure, less air molecules inside. Why do winds blow? If we're talking denser air exerting higher pressure, like cold air, high pressure, and warm air, low pressure, they like to even out. The universe likes to even out the playing field at all times. So if you looked at our body systems unit, you know that when you're breathing in and breathing out, you're changing the pressure dynamic. When you open your lungs up, you create a low pressure vacuum in your chest and high pressure outside. So air wants to come in and fill that void to even out the playing field, right? And when you breathe out, you're creating high pressure inside. You're crushing your inside, your chest, your thoracic cavity, closing that up, creating high pressure. And now outside, comparatively, outside is low pressure. So high to low pressure, it wants to run outside, then it evens out. Same thing with wind. So the flow of air is wind. Air moves horizontally is called wind. Air that rises is called an updraft, and sinking is called the downdraft. Taking a look at this diagram here, it is the wind pattern of Earth. So it follows a pattern through convection. Okay, so some of my kids, you might have learned this already, but the convection currents is based off of temperature. Okay, there's convection currents inside of Earth as well as on top of Earth. The sun rays hit an area, okay? They heat up that area and the air on top of that area. That warmer heated air is less dense. It rises up. If the air is then cooled, it becomes dense and sinks down, opposite. The heating and cooling of air is the rising and sinking of air creates the wind and is called a convection cell. So here we have this diagram of that circular pattern where the warm air rises. It cools off on the top at the high altitudes and falls down because it's so dense. It's cold, it's dense, so it falls back down. It hits the city and it gets warmed up by the ground because the sun is beating on the ground, high energy. It gets warmed up again and goes back up. That is our basic convection cell. Right here is a sea breeze version. Okay, so the hot air on top of the beach warms up, cools off, goes towards the ocean, cools down because the water is cool, and then it comes back in with the wind because if this was hot air here and it rises up, it needs air to come and fill that void, fill that space. So the cold air comes in, it's nice and dense, and then it gets heated up and it goes. And it keeps pushing the air like that, and that's how we get wind. Into the Coriolis effect. So the Earth rotates, every spot on its surface moves with it. So me, I'm standing on Earth, it's spinning, I'm staying with it, right? The places near the poles are moving slower than somewhere on the equator. Because the equator, you need to travel more distance, right? So you have to do it faster than on the pole. It's a smaller distance. Do it slower. Okay? No matter which way the wind blows, it will curve to the right in the northern hemisphere. Curving of the wind is called Coriolis effect. Okay? In the southern hemisphere, the winds will curve to the left. So check out this diagram here. So the rotation of Earth counterclockwise, and the other air is going this way. Okay? Because the Earth is rotating, the air that's here stays with Earth and its placement. So it moves with or against the rotation of Earth. Okay, so in the northern hemisphere it curves this way, and the southern hemisphere it curves this way. Now these circles that go like this, those are convection cells, heating and rising and cooling and sinking. Okay, these other lines that go like this and this, these are your Coriolis effect of winds. All right, and they have cool names: polar easterlies, prevailing westerlies, trade winds, trade is right at the equator, and then prevailing westerlies and polar easterlies again. Isobars helps us measure winds. This is how we map out air pressure. We use isobars. Okay, so isobars makes pressure patterns visible or easier to see. They predict, or they help predict, how fast air is going to move in a certain area. That can help us with predicting where storms might be. The big difference in air pressure over short distances create strong winds. So that makes sense. If there's a big difference from here to here, it's a short distance, but a big difference in air pressure, like I was super high pressure and that side was very low, the wind will flow that way really quickly to fill the void and balance out. Right? So in the middle there, the guy in the middle, he's going to experience extreme winds. But if we're a small difference of air pressure, so maybe I was +3 in isobars and that was +4, so he's only one more than me, the air will flow just a little bit. I'll just give him a little bit of air and then we'll balance out. No real big winds, maybe a breeze, gentle breeze. So this is shown by the spacing of isobars. Back up here, I forgot to mention, the line tells where the wind is blowing from the feathers on the symbol we're going to see. Okay, and it's used to show speed. So this shows the wind is flowing northeast, all right? And the length of the feather shows how strong that wind is. The circle on the bottom shows your cloud pattern. So clear is an empty circle, overcast is fully covered in, scattered clouds is a quarter, half is partly cloudy, and 3/4 full is mostly cloudy. Yes, how wind blows. So let's take a look on the left here. We have high pressure. Okay, it's circling around. High pressure means that the air is coming in and coming down because it's cold. It's getting cold, it's dense, it comes down. Dense air is high pressure, right? Opposite over here with the low pressure, right? That cold air comes in and wants to fill the low pressure air. The low pressure wants to get out of here. Low pressure is lightweight. He wants to go and fly, so let him go. He's hot. He's going up. He floats away. Underneath here, we have another example of the symbol to help you with weather patterns. All right, that is chapter 2, all about weather. Next, we're going to be talking about climate and the difference between weather and climate.